Hello, so welcome to this lesson on angle properties. I'm going to go over some angle properties mostly for this course because we do have quite a bit of different triangle stuff. And one of the things I find with these upper level math courses is that the textbooks and the people who wrote the stuff assume that you remember these properties, where in a lot of cases it's a little bit tough to remember them because we've learned them and then we've moved on. So I'm going to go over them, which will make life easier when we actually do trigonometry and stuff, so you won't forget them. So the first one is angles on a straight line. So what that really means is that if we have a straight line, any angle along that straight line is going to add up to 180. So for example, if we have angle A and angle B, what happens is that A plus B is going to equal 180 degrees. This is for any straight line. It's always 180 degrees. That one's super easy to remember. The second thing we're going to do is look at angle properties in parallel lines. So in all these cases, the angles are in parallel lines, and I've put in here that they kind of equal a letter, kind of to help us remember. So the first example, if we have parallel lines like this, the alternate angle kind of makes what we call a Z pattern. So if you see, it tells us that this angle here, if this is A, it is the same as this angle. And you'll notice it makes this really kind of Z pattern. So right here and right here, they're the same. And the same would go the other way. This angle here would be the same as this angle. So kind of cool. Remember the Z pattern for that one. The second one, which is our co-interior angle, again, it is in parallel lines. So they're parallel. What happens is that angles in the interior, for example, this A and this B, they add up to 180. So in this case, A plus B equals 180. And the same would be for if we had D and E, those ones would be also add up to 180. Okay, so it kind of makes this like C shape. Goes that way, or it can go the other way. The last one is corresponding angles. And so what happens with these is that this angle here is also the same as this angle right here. And you'll notice it kind of makes this like F pattern where this angle is the same as this angle. Now it does work the other way as well. For example, if this was B, this would also be the same. Okay, so we kind of have an F, but it's in another direction. It's kind of upside down and flipped. But yeah, that's the corresponding angles. So 3 of them for parallel lines, and all of them, these two have the Z pattern and the F pattern, show where they're the same, and the co-interior shows that they add up to 180. Okay, a couple other things to note, especially with trigonometry, is they're going to assume that you know this, but angles in a triangle, they add up to 180. So if we have A, B, and C, A plus B plus C equals 180 degrees. That one happens a lot in trigonometry. They kind of assume that you know that. So I'm going to tell you right now, if you're looking at a triangle, they add up to 180 degrees. Now with a quadrilateral, which is basically a four-sided shape. So that could be a square or a rectangle, just basically anything that is four sides. Doesn't really matter. A, B, C, and D, they all add up to 360 degrees. Okay, so a little bit different from the triangle. Triangle is 180. Quadrilateral or four-sided shape is 360. Last thing, opposite angles. Anytime you have something like a cross like this, if this is A, the angle that is across from it is also the same size. And these ones would be the same as well. Okay? Last thing we're going to do is I'm going to show you how to do an example, and we'll look at which rules we're going to do, and we'll look at how they come to be. So I'm going to start with angle A. Now, if you notice here, angle A is across from 70, which follows our opposite angle rule that's up here, and they're opposite, they're the same. So since A is opposite 70, we can say, excuse me, that A is equal to 70 degrees. Okay, now that we have that one, let's do B. So B, you'll notice, is on or it's a straight line. So since the one side is 135, we'll just subtract that from 180, and we get that B is 45 degrees. So again, right there, I just did 180 minus 135 to get that B was 45. So in total, making it 180. Okay, now that we have A, B, and C, you'll notice that C makes up a triangle with angles A and B. So that means that C is equal to 180 minus 70 minus 45. So when you do that calculation, 180 minus 70 minus 45, you get that C is 65 degrees. Okay, so now we've got all the angles on the inside. Let's take a look at angle D. Now you'll notice that angle D, it kind of makes this angle D makes this Z shape, and from above we saw that when you had the Z shape, they were equal to each other. So that means that if angle B was 45, then angle D must also be 45 degrees. Okay? D, C, and E are all on a straight line. So they make 180 degrees. So let's figure out what E is by simply doing 180 minus D, which was 45, minus C, which was 65. And we'll figure out that minus 45 minus 65 it equals 70 degrees. So E is 70 degrees. You can also get that from the F pattern as well. So there is always more than one way to get the angle sometimes, which is fine. And the last one is F. So two ways you can do that. Well, actually, I'm just going to do it this way. This whole thing should be, we have another 180 right here. So E and F should add up to 180. So 180 minus angle E, which was 70, gives us that angle F is 110 degrees. And there you go. We found all the angles in that section. We found A, 70, B to be 45, C up there was 65, D was 45, E was 70, and finally F was 110. So you kind of have to use all the different properties to kind of figure out examples like this. But in terms of the math, super easy. Just remember those properties. All right, thanks. Bye.